This is tutorial 1, and today I discuss about permutation. And many students have not subscribed this channel, so subscribe to get some videos. And if you like, then like and comment me. So let's start. First, we study definition. Let there is a function, bijective function. Let first that x is a non-empty set. X is a non-empty set. And any bijective mapping bijective mapping bijective mapping is a which is which is defined on the set to itself. Now this mapping is called permutation. This is the definition. Now if we take x has n elements, x has n elements, these are a1, a2, a3, up to en, then the symbol of the permutation is f. The symbol of the permutation, this is the symbol of the permutation is f. It is defined in this way. We'll take n elements. The number of elements is the degree of the organization. This is also the degree. So there are n elements. So this degree is n. So now the permutation is represented by in this way. And the last element is n. So the image of every element, the image of every element is written in this on last element will be F. So this is the symbol representation of any permutation. Now I am giving an example of a permutation. We will take two permutations on a set S. These are F and G. These are two permutations. Permutation on the set S, which have element 1, 2, 3, 4. So F is defined in this way. F is equal to, the permutation is defined in this way: 1, 2, 3, 4, and this is 2, 3, 1, 4, and the last, the G is defined in this way. The G permutation is defined in this way: 1, 2, 3, 4. This is 3, 2, 4, 1. So what does it mean? Actually, through this permutation, we can understand that one has the image under the map bijective mapping F. 2 means F1, the mapping from 1 to under the image F is 2. In this way, you can represent. You can take a diagram in this way. So if you put this, then you will take under F, these are 1, 2, 3, 4. These are 1, 2, 3, 4. So 1 has the image 2. This is 2. 1 is related with 2. 2 is related with 3. 2 is related with 3. And 3 is related with 1. And 4 is related with 4. So this is just I am writing F2 is equal to 3, F3 is equal to 1, and F4 is equal to 4. In this way, we can define the function g for the elements 1, 2, 3, 4 of the set. Yes. So this is the example. You understand? Now, in which condition permutations equality holds? So this is important point. Equality holds if F and G are two permutations permutation. So equality holds if we define that f is equal to g if and only if and only if fx is equal to gx for all the x belong to the set S. F and G are two parameters on the set S on S set on empty set. Then F and G will be equal if for all the elements in S, Fx will be Gx. It does mean that if you take, I am giving just three elements, 1, 2, 3, 1, 2, 3. If 1 is related with 3, 2 is related with 1 and 3 is related with 2, then under if we will take f1, then it is equal to 3. So under f and also under g both will be equal, means g1 will be 3, g1 will have to be 3. If f2 is equal to 1 is 3, then g2 will have to be 1. And at last, if f have to be 3, f3 is equal to 2, then g3 have to be equal to 2. If this happens, then we can write that f is equal to g. Otherwise, you cannot write. So the equality of two combinations you can understand. Symbolically, you can write that if f is equal to 1, 2, 3, 1 is related with 3, 2 is related with 1, and 3 is related with 2, then G have the same. This will be equal to G. They will be same permutation. Then F is equal to G. Now, one thing is to be noted that if S is a non-empty set, it has n elements A1, A2, means its degree is n, then its degree is n, n elements means degree is n, then we can formulate how many uh, uh, permutation through n elements, n factorial elements. So number of permutations you can make, number of permutation you can make is n factorial. I giving an example, like you take S is equal to 1 to 3. There are 3 elements. So according to the uh, uh, rule, there will be 3 factorial permutations, means 6 permutations. So we'll find out this is true or not. So first permutation, I am writing S1. This will be F1, sorry, F1. So this will be equal to 1, 2, 3, 1, 2, 3. This is also called identity because all the elements uh, has equal itself maps. All element maps itself. So this is the identity element called in the permutation. Permutation also forms a group. I will show this. So this is called identity. Now the first element I have found. Second element F2 will be 1, 2, 3, 1, 3, 2. Now there will be third element F3. This can be formed by 1, 2, 3, and if we put now here 2, 1, 3, it is a permutation. So others also I am writing F3, F4 will be 1, 2, 3, 2, 3, 1. How I am creating? First I put 1, 1, then I have put varieties 2, 3, 3, 2, then put 2 and 1, 3 and 3, 1. At last we can make F5 by 5 by 1, 2, 3. Here I will put 3, 1, 2 and 3, 2, 1. This is the maximum and you cannot make more than it. And F6, this is the last element, you can form taking 3 elements 1, 2, 3 and this will be 3, 2, 1. So there are 6 elements in the 6 permutations by you can make through an element n set of a set of 3 elements. So this is true rule. So you have n elements, n number of elements, then you can create permutation of n factorial times. So I've already said what is the identity permutation. This is called identity permutation. Every element maps itself. Every element. Then it is the identity permutation. Now, what is inverse permutation? Inverse permutation. Inverse permutation will take any any permutation. Yeah, I'm taking here n elements A1, E2, and in this way AF, and here I am taking A2, here I am taking another elements. These are also another one. These are B1, B2, Bn. All are image of the upper elements. U1 is the image of U1, B2 is the image of U2, Bn is the image of Ban. So, what is the inverse of the uh, mapping F, permutation F? Inverse permutation will be just we know for a bijective mapping if A is equal to B, then F inverse B what will be? F inverse B will be A. So this is the trick. Just we have now if F inverse is the F inverse is a function, then we have the image A. Means we just opposite the lower row to the upper row. So B1 have the image A1, B2 has the image A2. In this way, Bn has the image An. This is the inverse of the permutation. I hope you understand this. Now another topic, product of permutations. Product of two permutations. So what will be the product of two permutations? Now if we have two product, first I am giving mathematically. Mathematically what it does mean through mapping. Mathematically is mapping. Mathematically mapping I am first giving, then I am put a example. What does it mean? If F is a permutation or a function from x to itself x, and g is another function also from x to x, then we can product of f omicron g, product of the two functions, it will be just it will work just x to x. Or if we take change of the order g omicron f, then also we will get x to x. This is mathematical. And how it works, look this. If we will take f, I am taking three elements to clearly understand. A1, A2, E3, and image are B1, B2, B3. There are three elements in the permutation. And another permutation G. So here look, F maps x to x, means F A1 B1 also is actually any B1 any of A1, A2, A3. B1 is nothing except three elements A1, A2, A3. So B1, B2, B3 must be one of the A1, A2, A3 because there are six probabilities of having permutation from three elements. So B1 can be A2, B2 can be A1 or B3 can be A3. So different, no B1 cannot take, B1, B2 cannot take same element, they will be different. So you can understand that B1, B2, B3 nothing but rearrangement of these elements A1, A2, A3. So G have to be X to X means B1, B2, B3 also X because these elements, so this will be B1 X to X, B1, B2, B3 and another arrangement. Another arrangement is C1, C2, C3. These are the C1, C2, C3 nothing but A1, A2, A3. But here is the another arrangement. Here I am taking A2, A1, A3. Here I am taking A3, A2, A1. So these are the factors that these are the arrangement. So one thing is to be noticed that if we wish to uh, product of the two permutation, then the image set sets order and the data permutations elements order must be equal. B1, B2, B3 there must be B1, B2, 3 or in other words here I have taken B1 is A2, B2 is A1, B3 is A3. So here must have to be B1 have to be A2, B2 have to be A1 and B3 have to be A3. Then you can from the product, otherwise you cannot produce product. So there will be what? It will be then if these elements and these elements are equal, then you will get that A1 A1's image will be after the product of the two permutations will be C1 means C3, A2 will be C2 means A2 and this is C2 and A3 A3 have C3 means A1. So in this way, the product to permutation is done. I'm showing an example much better. Take F is the permutation F is there are three elements in F on this set 1, 2, 3. So this is 1, this is 2, this is 3. I am taking 3, 1 and 2 and now I am taking G. G will be what? G is 1, 2, 3, 1, 2, 3 and this is 2, 3, 1. So here you cannot do F, uh, F and product of the two permutation you cannot do directly. You have to change first that the order of the image of the first permutation must be equal to the elements of the second permutation. So here 3, 1, 2 and here 1, 2, 3. So I have to first change it. So how will I change? Here is 3 first. So I am writing 3 and 3's image is 1. So I am writing 1. There is 1. So I am writing 1 and 1 is 1's image under G is 2. So there will be 2. this is equal to G, and there is 2, 2 and 2 image under G is 3. So this is 3. Now you can do A omicron G means the composition or product of the two uh, permutation. Then it will be, now the image and the elements are equal. Then here 1 each, 1 has the image 1, 2 has the image 2, and 3 has the image 3. So your homework, I am giving a homework to all of you, must do and comment me. This is the homework, that if how you can obtain G omicron F. Send me it. How you can obtain G omicron F. I'll check it, and this is your homework. Send me, comment me, and I am today just finishing this class, and later in the another video, in another class, I will discuss how a how permutations on a given set forms group. So up to the class, thanks for watching. Thanks for and thanks to all who have subscribed this channel, and who have not subscribed, I must appeal subscribe this channel to get these classes. So thanks for watching.